So get this. What if an AI could tell you that you're at risk for a serious eye disease years before you even notice a single symptom? That's exactly the kind of incredible technology we're diving into today. A system that's designed to see our health future, starting with our eyes.
I mean, really think about that for a second. A piece of software that just looks at your routine health data and flags a potential problem long before your vision ever changes. And no, this isn't science fiction anymore. It's a brand new frontier in preventative medicine, and we're about to break down exactly how it works.
All right, so here's our game plan. First, we're going to talk about why prevention is the whole ballgame. Then we'll meet the AI predictor itself. After that, we'll peek under the hood to see how it actually learns. Then we'll see how it turns all that data into real advice. And finally, we'll look at what this all means for the future of healthcare. Okay, first up, a vision for prevention. You know, the biggest problem with so many serious eye diseases is that they're basically silent assassins. They can creep up on you for years without any symptoms at all. And by the time you realize something's wrong, well, a lot of the damage is already done. And sometimes it's irreversible.
And this is the absolute key. We have to move away from just reacted after vision loss starts. The real goal here is to get proactive, to spot the risk early and step in before the damage happens. Honestly, that's the entire promise of this technology. So that brings us to the AI-powered predictor itself. Let's take a look at the actual tools being built to make this whole proactive vision a reality. We'll use one specific system as our guide. So what is this thing, really? Well, at its core, it's a super smart machine learning engine. It doesn't just calculate risk, it's built to dig through mountains of health data to find these really subtle patterns, connections a human doctor might easily miss that point toward a future risk of eye disease. So what's the secret sauce? What is the AI actually looking at? Well, it's not guesswork. It's a totally data-driven process that analyzes 9 specific health metrics. And you know what? A lot of these are things your doctor probably already checks, like blood sugar, cholesterol, and blood pressure. The AI just connects the dots.
And from the outside, the process is beautifully simple. You feed it those 9 health numbers, then the AI runs this really sophisticated multi-algorithm analysis behind the scenes. And the output? That's the magic. A personalized risk score and actual actionable health advice.
But wait a minute. How does an AI get smart enough to do all this in the first place? Well, that brings us to our next section, how you actually train a digital doctor. I absolutely love this analogy because it just makes so much sense. We know the system was trained on a dataset of 20,000 patient records. The AI's job was basically to study every single one of them, way more than any human could, and just learn. Learn to spot the hidden patterns that connect certain health markers to actually developing eye disease down the road.
And this isn't about finding one single magic algorithm. Nope. The developers were really rigorous about this. After they prepped the data, they tested 9 different machine learning models. They have these fancy names like Random Forest and XGBoost, but you can just think of them as different experts, each with a unique strategy for finding patterns. They basically held a competition to see which strategy was the absolute best at making predictions.
You know, this whole multi-algorithm pipeline thing is probably one of the system's smartest features. It's just like going to a whole panel of expert doctors instead of just one. Each algorithm is looking at your data from a slightly different angle. So by comparing all these different takes, the system doesn't just find a good answer, it finds the most solid, reliable conclusion it possibly can. And the result of all that intense training and competition? An accuracy rate of over 95%. I mean, wow, that is an incredibly high level of confidence, and it just goes to show how powerful this approach really is. But listen, accuracy alone isn't the whole story. To be truly reliable, a model has to be both precise and thorough. Precision means that when it flags a risk, it's almost certainly correct. And recall means it's really good at catching most of the actual risks out there. With scores over 90% for both, this system proves it's not just making good guesses, it's consistent and it's sensitive. Okay, so the AI is trained, it's super accurate. So what? What does that actually mean for the person using it? Let's look at how the system translates all that complicated data into simple, useful advice. So what does a doctor or a patient actually see?
They get a really simple, clear dashboard. It shows their risk level, it can track how that changes over time, and this is the most important part. It translates all that complex data into personalized recommendations you can actually understand. It's meant to be a clear window into your potential health future. This slide really gets to the heart of it, doesn't it? A traditional checkup is just a snapshot, a single picture of your health on one day. This AI assessment is more like a continuous movie of your health, spotting trends and offering personalized advice as you go. It's a huge shift in how we can manage our own well-being.
All right, for our last section, let's zoom out. What are the big, real-world implications of a tool like this? I mean, where could we actually see this technology being used?
Well, the most obvious place is right in the clinic. Imagine this as a powerful screening tool for eye doctors. It could instantly help them figure out which patients in a huge population are at the highest risk, letting them focus their expert attention where it's needed most, long before symptoms ever show up. But it doesn't have to stop there. This kind of tech could be built right into telemedicine platforms or even mobile health apps on your phone, putting the power of early detection literally into your own hands. And for researchers, this is an absolute goldmine. A system like this is perfect for collecting massive amounts of data, helping scientists run huge studies to better understand what causes eye diseases and how they progress. And yep, there are commercial uses too. You could see health insurance companies using a tool like this to get a much more accurate picture of a person's risk, which could lead to more personalized insurance plans. Now, this is maybe the most critical point of all. The creators are crystal clear about this. This is a tool to help doctors and patients. It is not meant to replace them. Think of it as an assistant, a co-pilot, designed to boost human expertise with the raw power of data. And that leaves us with one last big question. We are building these incredible tools that can literally give us a glimpse into our own health future. So the question is no longer just, can we know? It's, are we really ready to look? Thanks for joining me.